lecture, we discuss on what is microprocessor and evaluation of microprocessor. Now, in this lecture, we see the microcomputer or block diagram of microcomputer. Here, on the board, this is the block diagram of microcomputer. This microcomputer mainly divided into 5 blocks. First, input, that is keyboard. Then microprocessor unit, MPU, the microprocessor unit. Then ROM, ROM, read only memory. We also called it as a program memory. Then RAM is a data memory. Okay. Then output device. Display the output. Okay. These are the 5 main blocks in microcontroller. First, input device, that is keyboard. Then microprocessor unit, MPU, ROM, read-only memory. We also call it as a program memory. Then RAM, also called as a data memory, and display unit, that is output. Or you can say here 7-segment display. The architecture of microcomputer with all essential buses and control signal line. First, started from input. Okay. Input device is keyboard. The instruction as well as data or program entered through the keyboard. The instruction as well as data prepared from particular program are entered through input device. This input device is a keyboard. We enter the data through the keyboard, that is input device. And next here, in this diagram, next block is a keyboard interface. Keyboard interface. When instruction and data is entered through keyboard, it does not possible to fetch the instruction directly to the MPU because MPU may be busy in performing previous instruction or another task. So it is stored in special chip. This special chip is keyboard interface. If your MPU is busy performing another task, so entered data is stored in this special chip is called keyboard interface. Keyboard interface. The next block is the MPU, microprocessor unit. This microprocessor unit, MPU, process system data and required control signal are generated through this MPU. All the processing and data flow is done through this MPU chip. Next is the read-only memory. We also call as a program memory. This is a permanent memory. It consists permanently stored program like a monitor programs. It has address bus, chip select and signal lines. It has a address bus here. It has a address bus is connected to this. It has an address bus. Then chip select line and signal lines also. It allows only to read store information. It allows only read information. This is the unidirectional. Data flow in only one direction. It only read stored information. Okay. Now next is the RAM. RAM is the random access memory. Yes, RAM is a random access This is a temporary memory. Temporary memory. It used to store data. It is a temporary storage device. Okay. This memory is a read or write also. So bidirectional data bus is a required. Here bidirectional data bus is a required. Bidirectional bus is a data bus. Okay. So here bidirectional data bus is a required. Memory is a temporary memory, storage device, reading and writing of data into this memory. Reading and writing data. Read or write. Random access memory is a permanent memory, whereas RAM is a temporary memory, whereas ROM is a permanent memory. Now next block is a output device, or you can say here 7-segment display. Output of the system that is store data in display interface are display on a screen segment display. Display interface here like a keyboard interface. Another block is the display interface. Okay. A special display interface circuit or IC is used to store data and drive to display. Okay. This is about the output device. Display interface, and display is a display on a screen. Stored data display using the interface, display on a screen, that is monitor, or you can say 7-segment display. Now after that you see the address decoder. The MPU connected to address decoder. The address decoder, it decode the address and select the proper chip or select the proper device. Address decoder is a decode the address and select the proper chip device. Then clock. Here clock is connected to MPU. Whole circuitry synchronized with a clock. The speed of system is depend on the clock frequency. Our speed is depend on clock frequency. Yeah. Power supply line. Power supply line here. Power supply line. And power supply is necessary to operate the circuit. Okay. After that we see the bus. In this diagram, see here address bus, data bus. Okay. So firstly, we know about what is bus. You can think of computer bus like a public transportation or school bus. This type of buses are capable of transferring people from one destination to another destination. Like these buses, a computer bus transfers data from one location to another location. The bus contains multiple wires with addressing information, describing the memory location where the data is sent or received. Each wire is bus carries a bit of information. Here you can say here address bus is a 16 line. Address bus carries 16 bit, or data bus carries 8 bit. Okay. So 16 bus in this diagram here, microcomputer 16-bit address bus is present here. 16-bit unidirectional address bus which carries the address of memories and peripheral devices. After that, we see the data bus. Data bus is a bidirectional. Data bus is a bidirectional. Data bus is a 8-bit data bus. In data bus, transfer the data among MPU and device. Okay. Power lines, you know, the power line, power supply is necessary to operate the whole circuit. This is about the microcomputer. Microcomputer having main 5 blocks: input, output, MPU, microprocessor unit, program memory, data memory, display, that is output device. These are the main 5 blocks. Buses, address bus, data bus. Address bus is a 16-bit, data bus is a 8-bit here, and clock. Clock is the clock frequency. Speed of our device is depend on the clock frequency. Okay, this is about the microcomputer system. Now we see the, or we move on our next point, that is our next point is block diagram of generic microprocessor. Okay, this is the block diagram of generic microprocessor. Generic microprocessor consists ALU, some register, program counter, stack pointer, instruction, decoder, time and control signals. So first we started from ALU. ALU is a arithmetic and logic unit. This unit is a 8-bit. ALU, this unit is a 8-bit unit. It performs arithmetic and logic as well as rotate operation. It consists of binary adder. Here, binary adder. Here consists of binary adder to perform addition and subtraction. Okay. The result typically stored in accumulator. When ALU perform any task or operation after the result stored in accumulator, or you can say process data stored in accumulator. The temporary register, this is the temporary register connected to ALU as well as accumulator. The accumulator processes the results stored in accumulator. Here, temporary register. The temporary register is used to hold data during the arithmetic and logic operation. In this ALU, here status register. The status register, that means flag. Status register we also called as a flag. The flag are set or reset according to the result of operation status register. Okay. Now one by one we see all the register. Firstly, temporary register. Temporary register. Temporary register is a 8-bit register. It also associated with ALU. Okay. First we see ALU. This temporary register is associated with ALU. This register to hold one of the data during the arithmetic and logic operations. Okay. Then accumulator, denoted by A. This register is denoted by A. A is a accumulator. This register is also 8-bit register. 8-bit register. This register also associated with ALU. The accumulator called A register. During the arithmetic and logical operation, you can say operation, one of the operand is available in accumulator. One of the operand is available in accumulator, and after the operation, result stored in accumulator. Okay, your process data stored in accumulator. Now next is the status register. This is the status register. status register is called flag, which consists of flip-flop. The flag are set or reset. This status register also called as a flag. And flag or set or reset according to the result of operation in status register. Okay. Now next is a HL register. Here is an HL register or data and address register. Data and address register. It is two 8-bit register. H is a 8-bit and L is also 8-bit register. So data and address register is a two 8-bit register that can use separately or as a combined pair. They are labeled as H and L. They are labeled as H and L. Data is stored in this register when used in pair 16-bit address can store. Okay. When we use this register in pair, so 16-bit address is stored in this register. Next is a program counter. Program counter, stack pointer. Program counter is a 16-bit register. And stack pointer is also 16-bit register. So program counter divided by PC. Program counter. It is used to point the address of the next instruction to be fetched from the memory. When one instruction is fetched from memory, PC is automatically increased to point out the next instruction. In simple way, we can say program counter store the address of next executable instruction. Program counter store the address of next executable instruction. And next is the stack pointer. Stack pointer is also 16-bit register. Stack pointer register used as a memory pointer or 16-bit address for denoting the stack position memory. Okay. The stack pointer is a 16-bit register used as a memory pointer for denoting the stack position in memory. The stack position in memory. Okay. This is the stack pointer. Next register of diagram is the instruction register. Okay. Instruction register. Instruction register is a 8-bit register. This register is the 8-bit register. The first byte of instruction. Okay. First byte of instruction is stored in this register. Okay. First byte of instruction is stored in this register. Again, I am using program counter. Program counter contains the address of next executable instruction. And stack pointer is register used as a memory pointer. Used as a memory pointer for denoting the stack position in memory. Now next we see the instruction decoder. Here instruction decoder. The internal instruction decoder. This unit decode the instruction. This unit is used to decode the instruction or interpret the instruction stored in instruction register. Instruction decoder decode the instruction stored in instruction register. It determines the exact step to be followed in executing the entire instruction. Okay, this unit instruction decoder. This unit decode the instruction stored in the instruction register. Next part is the timing and control unit. The internal clock generator is available in this unit. Here CLK. Previous diagram we also say that we also learn clock. Okay. So timing and control unit. The internal clock generator is available in this unit. This unit has the microprogram for all the instructions to carry out the micro step required in completing the instruction. This unit receives the signal from the instruction decoder. This unit receives the signal from the instruction decoder, generate from the instruction decoder and generate the control. This unit generate the control according to the microprogram or the instruction. Okay. So this unit receive the signal from instruction decoder and generate control and timing signals according to the instruction. Okay. These are the different blocks, registers in generic microprocessor. Here is again see the buses. Okay. Address bus, data bus. Okay. Address bus in this generic microprocessor 16-bit unidirectional address bus is here. 16-bit unidirectional address bus which carries the address of memory and peripheral device. Is identified here. Identify A0, A15, A0 to A15. These are the address bus. And data bus is a group of 8 lines. So the data bus group of 8 lines. Identified D0 to D7. Identified by D0 to D7. These are the 8-bit bidirectional data bus used to transfer data among the MPU and device. Okay. Now next is the control bus. Here control bus. Okay, another bus is used here. Control bus. So the control bus carry the control signal generated by control bus carry the control signal generated by MPU. This is about the block diagram of generic microprocessor. In generic microprocessor, these are the blocks: ALU, register, that is a temporary register, store the temporary data at the time of execution, accumulator, process data stored in accumulator, data and address registers, temporary register 8-bit, accumulator 8-bit register, data and address register also 8-bit register to hold the data, and program counter and stack pointer both are 16-bit register. Program counter store the next address of next executable instruction. Stack pointer point out the memory. Instruction decoder, it interpret the instruction or decode the instruction. Control and timing unit, this unit generate the control and timing signals to whole circuit. Okay. Thank you, students. Next lecture we see 8085 microprocessor and Venn diagram of 8085 microprocessor. Okay. Thank you, students.